Hello everyone, and welcome to our discussion about the six trigonometric ratios. In here, we're going to continue our previous discussion. Before we begin, I would like to say that our format, or sorry, my format in delivering my discussion or lessons is with the use of PowerPoint. It's no longer in OneNote. I found out that I can still use PowerPoint for free in my laptop, so that is a good thing because I prefer to use PowerPoint in delivering my lecture or lessons, which is for me, it's uh, let's just say it's more convenient and it's less confusing. It's less complicated than using OneNote. I mean, I could still use OneNote, right? I can still do that. However, um, for the sake of delivering the discussion and the lines, and like moving the slides to one another, I think PowerPoint is much better. All right. So without further ado, let's now begin. So let's have a recall. So this is a right triangle. So let's recall all the six trigonometric ratios. So we have this one, your sine x. All right. So your sine x is basically the opposite all over hypotenuse. By the way, speaking of opposite or hypotenuse, where does the opposite and hypotenuse located? So let's just say the given angle is here, right? So where do you think is the hypotenuse? Hypotenuse is basically the longest side of the right triangle. So this is your hypotenuse. Then we have your O. Your O is your opposite side. So opposite side is basically non-adjacent side, or in other words, it's not beside with an angle. So a side that is not beside with an angle is what you call it's what you call the opposite side. So this side is not adjacent to this one, so we can just say that the side here is the opposite. And this one, a side that is adjacent to the angle or it's beside with the angle, you'll call this as the adjacent. All right, that's it. So yeah, we have sine x is equal to uh, opposite all over hypotenuse. We also have cosine x. All right, and if you recall, it is adjacent all over the hypotenuse. We have tangent x, which is opposite all over adjacent. And we also have other three trigonometric ratios, which are the reciprocals of these trigonometric ratios. So we have cosecant x, which is the reciprocal of sine x, which is 1 all over sine x, in other words. Or we can just simply write this as hypotenuse all over opposite. Okay? So cosecant x is the reciprocal of sine x. In other words, it's hypotenuse all over the opposite. Then we also have secant x, which is the reciprocal of cosine x. So we will have hypotenuse all over adjacent. And lastly, we have tangent x, which is equal to, this is the reciprocal of tangent x. So this is adjacent all over opposite. All right? So you can memorize this one by using the mnemonic device, which is Sokatoa Toshakao. If you are not familiar with that, I suggest you should watch my previous videos about the six trigonometric ratios. Okay? So now that we recall the trigonometric ratios, let's now begin recalling our discussion last time. Last time, we had a practice about using a trigonometric functions in finding our x component and y component, wherein the angle is a special angle. Like for example, what is sine 45 degrees, right? What is sine 45 degrees? What is cosine of 60 degrees? Okay? So we discussed this one, and we even actually have a practice video about it. Now, the question here is that what if the angle is not special. Like a given angle, wait for a while, let me just charge my PC. Right? Going back, the given angle is not a special angle. It could be 1 degrees. It could be 40 degrees. It could be 100 degrees. So it's not special, you know? So how are we going to find the x component and the y component? All right? But before that, let's include other things to discuss as well, right? So we have this one. First and foremost, though, okay, let's just say that we have a given angle, all right? However, the only given is its location, but not the exact value, all right? So can we still find the ratio of a right triangle when the angle is not given? Which is this one. Can we still find the ratio even if the angle is not given? So that's the first thing we're going to discuss. Second, the one I told you earlier, what if the angle given is not a special angle? And last but not the least, how do we find the angle? Wait, sorry. How do we find the angle? So before we answer the question in like what if the angle given is not a special angle, let's try to what do you call this one? Answer the first question. Okay? Because before we proceed here, we must understand first the very first thing that you need to know, which is getting the ratio of the right triangle, even if the angle is not given. Then after that, we can proceed answering this question and this last question. Okay? So, can we still find the ratio even if the angle is not given? So, long story short, wait, sorry. Long story short, yes, you still can, right? You still can find the ratio even if the angle is not given. All right. All you need to do is just be careful at what angle you're referring to. Let me give you, for example. Let's just say that I have this simple right triangle, which is 5, 4, and 3. Okay. Now, what if my angle is here? Okay. Let's just say I'm looking for the angle here. Okay. So here, if this is our angle that we are going to refer to, can we still find the ratio even if the angle is not given? Yes. Okay. Let me give you, for example, sine theta. What is the ratio of sine theta? It's what? Opposite all over hypotenuse. So your opposite here is 3 all over. Oh, wait, no, no, no. Forgive me. It's not 3. It's actually 4. All right. Because your opposite side is here. Going back. So, yeah. So, this is 4 all over 5. That's it. Yeah, that's it. Even if the angle is not given and you want to find the ratio of opposite and hypotenuse, you can still find it. Just use this formula. All right. That's your answer. Okay. Now, how about if we find another trigonometric ratio, which is cosine? So cosine theta is equal to adjacent all over hypotenuse. So your adjacent here, it's 3, and your hypotenuse is 5. Done. That's it. Like, yeah, that's it. Okay. So even if the angle is not given, you can still find the ratio. All right, let's try other trigonometric ratios. Let's try tangent theta. Tangent theta is what? Opposite all over adjacent. So your opposite is your 4 and your adjacent is 3. That's it. All right. Now let's try another one. Cosecant theta. So your cosecant theta is just basically the reciprocal of sine theta, which is 1 all over sine theta in other words. So this is, in other words, 1 all over your sine theta, which is 4 all over 5. So if I'm going to simplify this fraction, I will have 5 all over 4. Okay? Or if you're not that type of guy who you know who do this stuff, just know its formula of the ratio of the sides, okay? Which is cosecant theta is equal to uh, hypotenuse all over opposite. Okay, that's it. All right. So basically, it's just the reverse of sine theta. So let's go. So just substitute. So you will have 5 all over 4. That's it. Okay. Now for your second theta, so you have hypotenuse all over adjacent. So your hypotenuse is 5, your adjacent is 3. All right, that's it. Now lastly, let's find your cotangent theta. So your cotangent theta is what? It is the reciprocal of tangent theta, or in short, adjacent all over opposite. So your adjacent here is 3 and your opposite is 4. And you're done, right? That's it, right? That's basically how you do it, okay? So long story short, you can still find the ratio even if the angle is not given, okay? Just be careful at what angle you're referring to, okay? Because let me tell you this. What if, wait, sorry, I actually erased everything, but yeah. What if the angle you're referring to is this one? By the way, the angle that I am talking about is the acute angle. So it could be either here or here, but not the right angle here, okay? I'm referring to these two angles. But yeah, going back, what if the angle we are talking about is here, this one, right, this one. So what are we going to do? Okay, wait, by the way, let me fix the number here. This is 4. So what are we going to do? So here, oh, sorry. You need to know the difference, or the difference. You need to know which one is your opposite and which one is your adjacent. Okay? So since the side here, by this one, it's adjacent to the angle, or in other words, it's beside to the angle, this is your adjacent. While your side here below, which is the base side, and the length is 3 units. And as you can see, it's not beside to the angle. So this is your opposite. Okay? So now let's try to find your sine. Okay? Your sine theta is equal to the opposite all over hypotenuse. So here, if your angle you're referring to is this one, or this one, then your opposite will be 3 and your hypotenuse would be 5. Okay? Earlier, we get our sine, but our angle is here, right? Which is this one, the red one, right? So what happens if what do you call this one? What happens if we have an angle here? So earlier, we found out that if the angle is in this place, your adjacent here is your 3 and your opposite is your 4. All right? So therefore, if you're going to get sine theta, I mean here, okay. So opposite all over hypotenuse. So your O here, it's your what? It's your 4 because it's not beside to the theta. Okay? Then your hypotenuse is 5. So you see the difference, right? You see the difference between the two. So yeah, now you know. So just be careful at what angle you're referring to. Okay? If your angle you're referring to is from here, then your answer is 3 all over 5. But if the angle you're referring to is this one, your answer is 4 all over 5. That's it. Okay? So to conclude, you can still find the ratio even if the angle is not given. Now, next question. What if the angle given is not a special angle? So suppose the angle is located here, right? And the angle given there is not a special angle. So it's not 0 degrees, 30 degrees, 60 degrees, 45 degrees, so on and so forth. Basically, it's not a special angle. So what are we going to do? So if the angle given is not a special angle, the result is that in terms of finding your x component and y component, you will not you will not get an exact value of the legs of the right triangle. Okay, wait. Let me fix that. It sucks. You will not get an exact value of the legs of the right triangle. Let me give you for example. Okay. Let's just say that we're going to use our knowledge in unit circle. Okay. So we have a unit circle. Oh wait, no. Hold on. So going back, we have a unit circle, which is this one, right? So in a unit circle, we always have a radius of 1, okay? Then we have an angle given here and its components. So to be particular, it's the x and y component. So suppose we have 1, then the angle here, then we have the x and the y component. So how are we going to, I mean, it's not that we're going to know how, but what will happen if the angle given is a special angle. So let's just say, let's try, this is 40 degrees. This is 40 degrees, all right? So let's find our x component. So here, remember that in the unit circle, you can find your x component by using cosine function. Now let's take a look. What is cosine 40 degrees? All right. So if we're going to use our calculator, because it will not give you the exact answer, by the way. So, wait. I have a scientific calculator on my phone, so forgive me if it takes time. So going back, so this is cosine 40 degrees. So here, wait, I don't know if, wait, for a while. If I have 60, oh, yeah, going back, so yeah. So if I have cosine 40 degrees, my answer here would be 0.77 approximately. So this is approximately 0.77 because in reality this is 0. Wait. This is 0.76604 and so on and so forth. See, it will not give you the exact value, right? So that's the that's the problem there. All right. I mean, even if there are special angles, will not give you the literal exact answer. Like for example, cosine 45 degrees. So what's cosine 45 degrees? This is what? Exactly square root of 2 all over 2. But if you're going to know its value exactly, you wouldn't know. You wouldn't know it exactly because this one is approximately 0.71. If you want to know it like like exactly, it's continuous, it's 0.707106 and so on and so forth. All right, so yeah, both of them will not give you exact value, but what I'm trying to imply here is that if you're going to use special angle, you can get its third form, or in other words, a term that has a square root, okay, or a root basically. So if, for example, use cosine 45 degrees, you have square root of 2 all over 2. If you use cosine 60 degrees, you will get what? 1/2. If you use cosine 30 degrees, what you will get? Square root of 3 all over 2. Oh, see? You see? So even if these cosine 30 degrees and cosine 45 degrees will not give you the literal number, but in terms of having a third form, you can still get its exact form, like square root of 3 all over 2. And this one, you can still get the exact value for this one. It's just that it's not literally, just like this one, for instance. Okay? But, if the angle is not special, just like 40 degrees, you wouldn't get an exact answer for that. Especially if it's in surd form, nah. There's no surd form for this angle. All right. So in other words, it is literally not a special angle. So there's no like square root of 2 all over 4 or something. No, no, not really. All right. It will give you exactly the value, which is basically uh, a value that has a non-terminating decimal, if I'm correct, or a huge number of decimal values. So you're going to approximate that into two decimal places, all right? Or three if you like to, okay? So the answer for this one, your x component is approximately 0.77. Now for your y, remember that you're going to use sine theta. So you have sine of 40 degrees. So what is sine 40 degrees? So this is sine 40. You will have approximately 0.64. So you see, if you're going to use your calculator, it will not give you the exact value because there's no exact value for this one. It's just that it really exists as that that number and that's it, you know. It has no surd form like square root of 2 all over 2 or something. No, just basically a number with a very huge number of decimal values. So yes, your y is 0.64 approximately. By the way, if your x component is in a second or it is in the two decimal place, you should also put this in two decimal place. Otherwise, you would be having a error. All right. So how would you know if you're going to have an error? Just take a look at the decimal values here. Make sure that they're the same. Okay. So let's prove that they are the same. We will use Pythagorean theorem. So remember that the Pythagorean theorem is a squared plus b squared is equal to c squared. Where your c, it's the hypotenuse or the longest side. Let's just say my A is 0.77 and my B is 0.64. Then my C, it's 1 squared. Oh yeah, it's 1. So if I'm going to get the value, all right, on the left side, I will be having approximately 1.00 in two decimal place. But exactly, this is 1.0025. And you see we have 1 squared here, so we have 1. You see, they may not be the same because 1 has a decimal value. 1 is just a normal number, if you know what I mean. It has no decimal value. But accurately and precisely, they are what? Closer to 1. So this is okay. But what if, for example, let's just say, yeah, one of them has a different number of decimal value. Like for example, let's just say your sine 40 would be 0.642, right? This is 0.642. So what will happen? Your B will be 0.642. All right, let's take a look what would be the value on the left side. Okay, so 0.77 squared plus 0.642 squared. So this is exactly 1.00500604, then 1. So do you get what I mean? I mean, the answer is still close. You know, they're still close to each other. Accurately, precisely, it's still close to 1. Okay? It still does. All right? But as you can see, there's a huge difference. You know, before it's like 1.0025, right? Now what happened? 1.005. So it's getting away from the 1. You get me? Because 1.0025 is less than 1.005 than 0604. But this one is closer to 1. Okay? So point being, in other words, if your x component you approximate it into two decimal place, you should do the same thing here as well. make it also 2 decimal place. All right? If this is 3, make this 3. If this is 4 decimal place, then make the other 4 decimal place as well. All right? Now, let's go back to our discussion. Okay? So yes, you will not have an exact value for your legs of the right triangle. Okay? But here's the thing though. Let's just say you have a hypotenuse. Okay? I want to find my x and y components. In a unit circle, it's easy, right? Because your hypotenuse is always 1 and you have your given angle here. So you can find your x by using cosine theta and your y as sine theta. So this is, in fact, easy, okay? But what if the hypotenuse is not 1? Let's just say, for example, 4. So do you think uh, I'll be using these formulas to find each x and y component? The answer is no. You will be using different formula. Okay? In a unit circle, your hypotenuse is always 1 unit. This one, on the other hand, it's not 1 unit, rather it's 4 units. So how will you find the x and y component? Okay? So recall that if you're going to get your x component, okay, x component, then your y component, you will be using what? Opposite all over. Oh, wait, sorry. You will be using, yeah, cosine and sine, right? For your x, you will be using cosine theta. So what's cosine theta? Cosine theta is basically what? Adjacent all over your hypotenuse. Okay? So which one here is your adjacent, your y or your x? So since your x is beside to theta, so that will be your x, right? Then your hypotenuse is your 4, okay? Which is 4. So to find your x, okay, you put 4 beside it, and you will have 4 times cosine theta is equal to x. And that is how will you find your x. Now for your y, you have sine theta is equal to opposite all over hypotenuse. Your opposite here is your y since it's not beside with the angle. Your hypotenuse is your 4. So let's find your sine theta. So put 4 beside here, you will have 4 sine theta is equal to y. So that is how you will find your what? Your x and y components. So therefore, your x component would be hypotenuse. Oh wait, let me fix that. Oh wait, never mind. Hypotenuse times cosine theta. And for your y component, hypotenuse times sine theta. Okay? Why is it that I include this one in this question? Like, right in this question, we're just talking about what if the given angle is not a special angle? Because you will be using this one to find your x component and your y component. All right? Even if the angle is not special angle or what. Let me give you, for example, your hypotenuse is 10, and the angle given here, it's 25 degrees. Let's find your x and your y. Okay? So how to find your x? So your x would be hypotenuse times cosine theta. Your theta here, it's 25 degrees. So your hypotenuse is your 10. So your x is 10 times cosine of 25 degrees. So what is your answer here? So this one, 10 times cosine 25, will give you approximately 9.06. So this is approximately 9.06. Now how about for your y? So your y is hypotenuse times sine of 25 degrees. So this is 10 times sine of 25 degrees. So you will have 10 times sine of 25. So you will be having approximately 4.23 units. So this is 4.23 units. Okay? So as you can see, you will not have an exact value, you know? Now, how about let's just say we have a special angle. All right, so that you could understand me very well. What if we use 45 degrees? It's still the same. Use the same formula. Okay? So here we have hypotenuse as your 10. Wait, let me just change the angle. Forgive me. The angle here should be 45 degrees. So yeah, going back. So we have 10 times cosine of 45 degrees. So remember that cosine 45 degrees is what? It's square root of 2 all over 2. 10 and 2 are both divisible by 2. So 10 divided by 2 is 5 and 2 divided by 2 is 1. So hence you have 5 square root of 2. Oh, see, you can get the answer exactly. Now for this case, you will do the same thing. 10 times sine of 45 degrees. So 10 times sine 45 degrees, it's still square root of 2 all over 2. And 10 and 2 are both divisible by 2. So 10 divided by 2 is 5, and 2 divided by 2 is 1. So you will have 5 square root of 2. Or you see, if the angle is special, you can find the exact value. But if the angle is not special, like 45 degrees, you will have an approximate answer. All right? Like here, 9.06 and 4.23. So overall, if the angle given is not a special angle, you will not have an exact value for the legs of your right triangle. Okay? And I introduced to you, like, what if the given hypotenuse is not 1 but 10? Because we all know that in the unit circle, we use hypotenuse of 1 because the radius is 1 unit long. Now, how about if the hypotenuse is not 1? So you will be using this. Okay? You will be using this one. All right? So that's it. Now, before we continue, I would like to stop right now because after this, we will be discussing how are we going to find the angle. And I have my own limited time in, limited time in discussing this video because I must only discuss it within 30 to 40 minutes or maybe less than 30 minutes, which is much better. All right. So the only thing that I can say is that just just wait for my videos, okay? Or in the meantime, you can just search in YouTube on other topics that you still want to learn. All right. So that will be all. Right, and see you guys soon.